Hi, Hilary. Welcome to DEALITT podcast. I'm really happy to meet you here today in DEALITT podcast, where we like to meet scientists, CEOs, and special people like you. You have a long career in ground engineering. You are Associate Special Director of the Ground Engineering Department in Tony G. Hilary, how are you doing today? If I can start asking this question, I'm really happy to meet you here today.
Yeah, no, I'm great. Thank you for inviting me.
This is a really good opportunity for me and for everyone watching us because we are having you. Hilary, you have a high experience. If I can make an introduction, you have a high experience in design, planning, management, in ground engineering field. You have spent more than 25 years of experience in Arab consultancy. Correct me if I'm wrong. This is one of the best consultancy in UK and out of UK. Hilary, how do you feel about this long career and great achievement that you spend it in ground engineering and your high contribution?
So yeah, well, I started out really when I was 16 when I attended a lecture about civil engineering, and I thought, yes, that's what I would like to do. And so after university, I started out with a company that was called Sir Alexander Gibb and Partners, which is now part of Jacobs. So I worked there for a few years, and then I went into research at the Building Research Establishment, where I was there for a few years as well. And then you're right, I was with Arup for 24 years, and I'm now working with Tony G. So yes, so really,
it's a great achievement. Yeah, I know it's a great long journey. I think you walk from research to the industry. I will not ask you how many emails you receive per day because you are a very busy person. I know you very well. I would like to dive with you in a different questions, and but I would like to ask some of the questions that I ask it with any person I meet. Like, how do you like to do, what do you like to do in your free time, usually as a geotechnical engineer? Because geotechnical engineer sometimes could be how to say, repetitive sometime. Yeah, not everyone like it, but it's really great sector.
Yeah. So I spend time, I prepare for training activities and other contributions within the industry. So we have we do a lot of training at Tony G. I spend time reading and preparing for that. I also contribute with reviews of documents, preparation of documents. I'm a member of various outside organisations, so a member of the Deep Foundations Institute Committee on Foundation Reuse, a member of some of the AGS working groups. I also support the BGA Early Careers group. I used to work at BRE, and I periodically organise reunion lunches. So geotechnics for me is something I like to, it's my personal interest as well as my job. And I enjoy, so LinkedIn is great. I enjoy reading posts and communicating with people around the world. I see a lot of effort and research and construction going on around the world, and I like being part of a worldwide community. And then other than that, really my spare time spent with my family. That's it really.
Family comes first. Yeah, family comes first. If I can ask it like in a different way, what keeps you motivated to continue performing and continue achieving your targets every day?
Yeah, well, so I'm very grateful for the career I've had, which seems to have gone by incredibly quickly, really. And I've it's been a huge part of my life. I mean, you know, I believe in the people around me. I believe in our industry generally. You know, I've had a good career and I want to give back and help our younger engineers, because our field, you know, now it's so vast. I like helping to connect people. You know, I'm really believe in collaboration and a team approach, and that's what we need to do across the world to you know, assist the future as best we can. And I'm motivated by the people around me, the people I work with, and I enjoy sharing ideas with other people in our industry, and you know, collectively learning about all the different things that people are you know, endeavoring in.
Yeah, that's really great. That's really great. More than enough. Yeah, I think you've done a lot of job, to be honest. Hilary, I would like to take it from down to up. Like you started your career as a researcher, as a geotechnical researcher after you graduate, and in building research establishment, and the work involved a lot of lab testing, mainly CPT testing. Would you like to take me through this period? How have you seen the research change? And yeah, maybe this is.
Yeah. So I didn't actually start at BRE. I started at a company called Give, and I was 4 years with them, working on the Limehouse Link project in the Docklands. And it was with that experience I got chartered. But I sort of come from a family with a teaching background, really, and I saw the job advertised at BRE, and the idea of going into research for a while really appealed to me. You know, BRE has been a huge force for understanding both fundamental and practical soil mechanics and geotechnical engineering. It's had at least 10 ranking lecturers came from BRE. It was exciting to go there, and although I sort of joined at a time when actually the peak in numbers was coming down, it was, you know, it was in the 1990s. It was a really exciting time for research in geotechnics. You know, there was a lot of work going on about variation of stiffness with strain level and fundamental soil mechanics, and new techniques were emerging. A lot of work on geophysics and in situ testing. So it was very exciting. I did a major 4-year project with the Norwegian Geotechnical Institute, the Laboratoire Central des Ponts et Chaussées in France, the Danish Geotechnical Institute. We were looking at semi-empirical design procedures for foundations, and I really enjoyed liaising with the international organizations. I was particularly interested in a device called the cone pressure meter, where you have a pressure meter section mounted behind a cone penetration testing head. And research had been done around the world really at that time on that device, including people in sort of Canada and Oxford and Italy. Jeffries and Bean had not long published their paper on the state parameter for sand, and people have been looking at using both the cone part, you know, which relates to spherical cavity expansion, and the pressure meter part, which relates to cylindrical cavity expansion, to understand the state parameter in sand. So, you know, I was looking at using the cone pressure meter to examine that in a site in Norway called Holmen. So that, you know, that was really exciting to do that, and plus we looked at sites in clays as well.
Important, I think so. If I can stay in the research period and combine it with your practical experience, from your practical experience, what area in the industry does there need to be more research from your practical experience?
Yeah, so I think that you know, research has probably changed gradually since about the year 2000, and I think that lots of aspects, you know, are being covered. You know, at the time, numerical modelling was still relatively new, but now there are numerous soil models that have been developed, and research into them. Research has continued into the complex behaviour of soils as particulate materials. New construction areas like monopiles for offshore wind, resilience, sustainability, renewable energy, nature-based solutions. They become key aspects of research, and our ability to gather and process large amounts of data has increased. So really, what?
Yeah, yeah. I think you mentioned a lot of CPT testing. You mentioned a lot of lab testing, as you mentioned, and you contribute a lot to that. I know you also done a lot of, and you're still doing a lot of sustainability work and reusing foundation. And I will come back to this point later on, but I would like to take it gradually and come back a little bit to your after your research period. You went to the industry and you start building your practical experience, because I know you love to see the projects if I can see it, and you involved in different kind of sector: residential, commercial building, tunneling. I can mention a lot of projects. I can't mention all of them. Sorry, Hilary. So, for example, you work in limestone tunnel, Glazenduk, Channel Tunnel at that period. A lot of school work, residential and commercial building in the heart of London. So, if you can take me through this period, and can I ask this question: how the design has shifted, mainly the ground engineering design, and what kind of improvement we can do what kind of ground engineering improvement we can do still in the design with all of this period. It's a long experience. I can see the design has changed, and you mentioned also the numerical wasn't there, and it becomes part of our design.
Yeah. So I think that's a key thing, is that we now have widespread use of numerical modelling. That ought to lead to more efficient designs, but really it requires good understanding of the input parameters and the performance of the program. And if people don't understand the soil parameters that they are putting in, then there's a risk. So it's still important to carry out simple calculations based on understanding of the issues and to check against published experience. There is a new Syria Guide C791 out called The Management of Advanced Numerical Modelling and Geotechnical Modelling, which has tried to address this difficulty. So basically, fundamental understanding of soil mechanics and foundation behaviour is still crucial. So basically, along with published precedent, that's as important as ever. And I think that really, with all the other skills that young professionals need to develop now, there needs to be time to develop fundamental understanding of soil mechanics and geotechnical design processes. So other things that I think have increased the range of skills that engineers now are, with coding and automations come in, use of statistical analysis increasing. We now do carbon calculations, use of geospatial data and digital data, including LiDAR and satellite data, has increased.
So I think this is all really important. I think now it's also important topic in research both. If I can take it also to your project, you've done a lot of work in not most of the work, but outside of the UK. This including Qatar Museum, some of the project also in Libya, Middle East mainly project. Can I ask what are the design challenges and also management challenges, standard challenges that you have involved in this geotechnical design project outside of the UK, if you can learn from that?
Yeah, so firstly, I would say that actually in the context of everything, my experience overseas is really pretty limited. But I always enjoyed interacting with designers from overseas. There's always the issue of different codes, but that's not really a major obstacle. I mean, understanding the different ground conditions is key. So, gather as much information as possible from geologists and literature sources is important. Foundation testing is also advisable to support designs when you're dealing with ground conditions that you're not familiar with. You know, you might have to work with local ground investigation companies and different techniques. So you have to understand what techniques are available and decide how the results can be interpreted. You know, and that's quite exciting, really, because you can get back to fundamental soil behavior and understanding about potential sample disturbance effects.
The ground interpretation, the analysis of the ground interpretation.
Yeah, and then around the world, there are variations in foundation type and construction methodology that people do. So it's important to appreciate what's available and what the precedent is in similar ground conditions in those countries. And I think, you know, clear and frequent communication is key, and particularly with different languages involved. And really, ideally, you want to have an office local to the project also.
Yeah, this is really important, I think. I would like to speak and ask you about a topic that many people now, many engineers, many geotechnical engineers speak about, which is sustainability, geotechnical sustainability engineering. I know you have published many papers that are related to reusing foundations, reusing pile foundations in the heart of London, and as a case study. And can you take me through your experience that's related to sustainable geotechnical engineers, and what are the challenges of reusing pile foundation or reusing foundations as part of sustainability? What make people that unable or to do it?
So basically, you know, sustainability is now a fundamental consideration in all our designs that happen now. And many companies have teams that are specifically dedicated to sustainability. In the companies that I've worked with now, specifically, we you know, addressing sustainability, we're designing foundations for onshore wind power and offshore wind power, undertaking risk assessments on a large scale for network rail, national highways to ensure future resilience of their infrastructure. You know, we're using carbon calculators. We started writing sustainability clauses into our piling specs, working on foundation reuse projects, reinforced earth, you know, that's coming in a major way. We're using numerical modeling to help refine our designs. We're specifying monitoring to ensure our design remains within expected behavior. We're using the observational method. We're specifying pile tests to refine pile designs. We're using our geological expertise to make sure we understand the geological risks. And, you know, so it goes on. And in recent years, contractors have become very engaged in decarbonisation of foundations. And there's been the recent guide on the circular economy by the EFFC and the DFI. So about foundation reuse, you know, that's attracting interest all around the world, and particularly in the UK, the Netherlands, and Germany, and now more recently the US. So really, the challenges are, so really for optimal reuse of foundations, you do need good historic information on design and construction, because having little or no information can lead to very extensive and costly investigations with more risk, which gets carried down the line. You know, it's important to understand design and construction processes at the time. That helps you understand the potential foundation capacity. GI is more extensive than a normal project, and you know, you need to get in as early as possible, which often means that you're working in, you know, you might be working in an existing building with limited access and headroom issues. You do need a very clear strategy around design and investigation, which the client needs to fully understand. So the design responsibilities need to be very clearly understood from the start. So the client and insurers will carry the risk of latent defects associated with the existing foundations. And they really need to understand that, and the responsibilities between the geotechnical engineers and the structural engineers. And that everyone needs to recognise that during ground investigation, there can be issues discovered which might fundamentally change the strategy. So, but you can to build that into your strategy early on, so it's not a showstopper. and the thing about foundation reuse is the risks are progressively reduced as the design and the investigation proceeds. And you do have options to strengthen foundations, though these are typically more complicated than they would be for a new build. But nevertheless, you should be thinking about those from the start. You do need careful monitoring to close out the risks during construction. And design costs are typically more than new foundations, and the design will probably typically receive more scrutiny from reviewers and checkers. But you can overcome all these challenges by good communication and careful joining up between all the parties.
I think so. Yeah, this is one of the key. In geotechnical engineering, and you mentioned a lot that data management, ground interpretation, this is a lot of data. So data management is really important in geotechnical engineering. You agree with me? So in regards of sustainability and data management, and a lot of engineers, they speak about data management and geotechnical engineering. How would you think that geotechnical data management will play a significant role in geotechnical in sustainable geotechnical engineering?
Yeah, so data management is clearly an important resource for sustainability in the future. So already that's becoming clear, and there are many areas where data management is key. So we just talked about foundation reuse. That's a key area, both for data gathering for existing foundations that we want to reuse, but also thinking about reusing those foundations in the future. We need to store that data for the future. There is a case for even a national database of foundations and any measured performance, or even pointers as to where to find that data to facilitate reuse in the future. And I know it is happening that people are starting to build in monitoring, we're calling them sort of smart foundations, alongside as digital twin models to help them understand current and future performance. And then for foundations generally, I mean, it's availability of records helps understanding of existing foundations and obstructions to new works. But also in some instances, documenting these massive man-made foundations we get from power stations or offshore wind farms, storing that data for the future is hugely important. And then ground investigation, or the BGS are already working hard to make more widespread availability of the factual data from the ground investigation, not just the borehole logs, and other European countries are doing this also. I noticed recently Arab have set up a tool that will look at the ground conditions in London, and advise on whether sort of pile foundations or shallow foundations would be required.
Interesting.
There's the recent work of the Government Office for Science and the Geospatial Commission on the National Underground Asset Register to locate services across the UK, particularly in congested urban areas. And they're looking to expand this database to consider other areas as well that help urban planning. And there are definitely other areas of data management that will assist urban planning and sustainability, for instance, district heating networks and positioning of data centres, locations of geothermal energy boreholes and piles, maps of basement footprints, and depth of retaining walls to help understand groundwater flow, tunneling, tunnel location design, construction, movement monitoring, and then monitoring data. I mean, monitoring is going to be really the key to help us refine our designs in the future. So monitoring and case studies, and making these case studies available is as important now as it ever was. And clearly, there's now the use of remote monitoring from for instance, from satellite data, from LiDAR data. We're beginning to, rely on this around the world to help us understand, resilience of slopes, for instance, resilience of infrastructure.
How to capture the information, how to understand the ground interpretation in a better way. Honestly, Heather, I would like to ask you much more questions, but I think we need more session, another session. If I can, with all of your experience, if I can end up with this question, what is your advice for the new generation of the geotechnical engineers who will start now and want to build their career? What is your top advice?
So my advice is, carry out the task you're given, but just make sure you understand the background and why you're making the assumptions. And I think there is core geotechnical knowledge which a company can define. And I try to do this myself. And so this needs input from senior engineers to make sure they can enable this learning process. I think that if developing geotechnical engineers can have this core understanding, they have the tools to tackle all these additional specialisms and additional skills that have been developing in recent years. And we can't all be specialists in all areas. So some people will be more informed in one area than another, and some people be more suited to one area than another. But we work in teams. And that's important to remember that. And the thing is, we should all try to understand the basis for the specialisms that everyone's carrying out, so we can see how it's all connected. And actually, if we try and keep our core understanding, keep learning, keep growing as geotechnical engineers, we'll be able to move around different specialisms. So it means that early routes don't need to define us. That we have the tools. We have the tools to be able to meet different challenges as we go along. And really, geotechnical engineering is just an amazing field, and it's a process of lifelong learning and interest.
It is. I totally agree that it is amazing field. Honestly, Heather, I'm really happy to meet you here today. Honestly, in DEALITT podcast, and I really would like to meet you again. Honestly, you're a great person with a great experience, and everyone speak that you are one of the best geotechnical engineers. And thank you everyone for watching us today in DEALITT podcast. Please feel free to leave your comments and questions, and we will come back to you. And please wait us for our new session. And thank you very much.
Thank you.
Let us this.